close this thing up. Okay, probably Mason, and I'll just write yeah man, Lua. Okay, and this is something. Oh, no, no, what's wrong with where is harpoon now? Okay, let me find a small thing, and yeah, I'll Lua. Yep. Uh, Instead of this, I select a block. Okay, select a block. Okay, select it till end. My Vim motions are still bad. I don't know why. Yep, need to work on those. Okay. If I do this now, I need I need config. I need a config. I need config. I should need a config. I'll just go here. Lua require head file. Okay, harpoon. Navigate to next mark. Navigate to previous mark. Okay. Navigate to file. Navigate to next. Navigate to previous. Oh, I could do that. You can also cycle the list in both directories, and there are. Oh yeah, I can do harpoon on terminals too. That's something I have to figure out. Maybe I'll stream it. Yeah. Yeah. Comment down below. I'm not used to saying those things. It just makes me cringe a bit more. So yeah, let's try to figure this thing out. Uh, I pa, 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 pa. uh Harpoon mark, harpoon UI. I need both. Or else I can just do this thing. I'll take this elsewhere, and probably quitting this thing will get me harpoon down. Lazy. Do I have it? Do I have harpoon? Bitch. Uh, oh, my bad. Did I just copy it wrong? Uh, I guess I made a mistake there. My bad, my bad, my bad, my bad. Okay, let's quit and let's get back. And yeah, harpoon is in on. And I'll go to my setup where my all my key maps are available. I can just do if I go here, you can set a key map for this. Mm, key map, key map, key map, key map, key map. Vim dot key map, key map dot set. In normal mode, if I do what do I say? Leader and A will mark the file. Uh, Add file. Okay. That'll be cool. Uh, I guess I never used lazy for my thing, but looks like I can do that. Okay, I should just add it as a command probably. Command lua vim.buffer. And yeah, end it as cr. So if I do this, Okay, not an editor command. Why? Oh, oh, my bad. Uh, so yeah, I need to check my UI first. Let's go toggle quick menu. Should probably need this. Uh, okay, my bad, my bad, my bad. Yeah. So if I not leader A, it's uh control E. Uh, hmm, okay, how do I map something to my control? Okay, for now, let's just keep it leader E. Okay. Yeah, if I do leader E, oh, Lua daughter Lua required. Fuck. Ooh, I can. Leader E fits a bit more. Can just do leader E. For leader E, I need it for my remaps. I need leader E for my remaps. So, or else can I do leader A? I have leader head, leader S. I got it marked. I have use case for all these things. So I need QWRTY QWERTY. Um QWERTY. Fuck you. Yeah, like I call you on for HTTP and I'm teaching you guys NeoVim. So deal with it for a bit. Got a really numb feet right now. But yeah, we'll be done with this thing quick. Remap to control how uh, all I have is this uh, uh, control how control E. No. uh Control. Okay, I can just do this. Uh, Key map and NeoVim. I guess my typing went to shit after switching OS. Or oh, you never know. Pup, 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 pup. Okay. Yeah. Leader A is fine here, sir. Not leader. Yep. Successfully successed. Um. Yeah. I need a couple of this. Okay. Uh, Leader. Replace W. Replace Q. Uh. For now, 4 tabs are fine. I need one more tab. Replace D. Okay. Uh, I'm so used to doing these things. I guess I can't change my habit. Okay. Nav file. Okay. UI nav file 3. I can just map UI nav file. This is the function name. Okay. Ooh, okay. How do I? My bad. Still not that advanced. Okay. Since we're nav file, yeah, nav file one. Sorry, 1, 2, 3, 4, 5. Okay. Cool. Okay. Harpoon is marked. Oh, sorry. Setup. Oh, my bad. UI. Source. Yep, working fine. God damn it. It was tough to get this shit done. And I don't know how the things that my NeoM does. Like it's too convoluted right now. I might take some day and fix and clear this thing up. Or else I'll just run a random stream just to figure out new plugins and the things that I want and try to make the config a bit more light. Right now, like it's like it has all the stuff I need. It's just that I can lose few and I would still be fine with it. So yeah, I'm kind of running for the minimalistic setup. Hopefully, I don't know, man. I don't know. Maybe may not be. Huh? Uh, yeah. Transparency true. If I wow. Okay, never knew that. Uh, where was I? Okay, let's just get back to the topic we had in our head. HTTP server from scratch. So go routines. Before go routines, I need tests. Yesterday we figured out imports, how imports work, and imports seems to be doing really the job that I need. Uh, oh, I did not quit and reopen it. Uh, Server will be my main file. Handler is my second file. Oh, I probably can add this to. Uh, where is my NeoVim setup? Uh, but requiring something every time. Uh, I don't know. This feels heavy a bit. I'm pulling the entire file down for one small operation. Can I not just get the yeah, it's fine for now. It's fine for now. I need to add few more things. Uh, uh just this to next and previous. I kind of like them now. Uh, UI nav next and nav previous. Okay. Uh, yeah. Okay. What do I want them to be? I do control OP, control O for yeah, and control P basically doesn't do shit that I need. Setup. Control leader O for next, leader P, leader O for next, leader P for Okay. Okay. Leader O, leader P, leader O, leader P. It's quite slow. Can't assign string parameter. My bad. Leader O, leader P, leader O, leader O, leader O, leader O. You can just toggle for a bit. Leader P, leader P, leader P. Leader O is quite fast. Okay. Leader P is kind of slow. Why? Mm, do I have the privilege to see the code base? Yes. And nav P, Lua, Harpoon, UI.lua, and I'm searching for a function called nav prev. Okay. Yeah. Get current marked length current. Okay. Function nav prev is like getting current, get current index. Function get current index. Name buffer name. Ooh, too much Lua Sigma. I barely understand this shit now. Yeah, I get basics of Lua, but I never want to write in Lua. Wanted to. I can change my opinion, but for now, nah. It's a lightweight thread manager with Go routines. Start a new Go routine by running. Okay, you know what? Run. Mm, what it's doing? Go say hello. Say hello, and function says as a string, and I equals to 0, I less than 5, I plus plus. Time dot sleep 100x time dot milliseconds, and it will sleep and print the string. And faster the execution, the faster the set happens. Can I, yeah, time dot milliseconds? Time, what does time dot milliseconds give in this case? Run and program executed. So fun, go by example, go routines. Okay, you just gave me the same shit. No, oh, sorry, bro. You gave me something useful, but suppose we have a function called fs. Here's how we call that in usual runtime synchronously to invoke. Will my debugger get fucked by this? Not really sure. Yeah. Oh, when I have two functions to fuck with, it's really fun. But I need P. P is bloody slow. Wow, it's too damn slow. See the amount of effort. Updated. Instant takes time. Okay. Yeah, that's something. I don't know. I don't think I have the balls to report it to Prime. Yeah, let's go Prime. Fix this for me. Uh, I don't think he'll. He will. He will. But uh, yep. Go routines. Let's just use lightweight concurrency model. Go routines. You just give me the lesson. Understanding go routines lightweight. Yeah. Go routines are one of the Go's core feature for handling concurrency like Java threads. Unlike traditional data heavy threads, Go routines are lightweight and managed by Go runtime, allowing you to run hundreds or thousands of them simultaneously without significant overhead. What are Go routines? A Go routine is a function or a method that runs concurrently with other Go routines in the same address space. When a Go routine is created, Go runtime schedules manages independently, allocating resources and switching execution between Go routines as needed. They are incredibly efficient because Go routines have small initial stack size, typically around 2 KB. Go routine manages stack growth as needed, unlike threads, which require a pre-allocated stack. Okay. Go routines are scheduled by Go runtime rather than by the OS. Okay, this is something I don't know. I feel iffy about this thing, which helps to reduce the overhead of context switching. So Go decides it, not OS. I mean, it might outperform in Windows at least. Like if I don't know, OS, I like Ubuntu flavor a bit more. I mean, I can leave my memory up to Ubuntu for a bit. But yeah, Go runtime, they might have reasons for it. I don't know yet. Time dot sleep, time dot seconds. Okay. Mama. Go routines are managed by Go runtime scheduler, which maps multiple Go routines onto a small number of OS threads, which this is achieved using. Oh fuck! I can't read. Okay, using model called M scheduling, where M routines are multiplexed onto N OS threads. M routines are multiplexed onto N OS threads. Let me write that down. M routines are multiplexed onto N threads routines. So every routine, there's a possibility that in one thread there are multiple routines going around. Not a possibility, that's what it says. Okay, and somehow it handles it well. Okay. Go routine G. These represent individual functions or tasks that run concurrently with Go application machine. M. This represents an OS thread that is capable of executing Go routine. Each thread has its own associated CPU state, memory stack, and stack as managed by the OS. So Go routines run on machine threads. Okay, so a logical resource that holds a run queue of Go routines that need execution. Processors are the bridge between Go routines and OS threads, with a one-to-one mapping to CPU core by default. Okay, controlled by Go Max processor environment variable. The scheduler assigns each processor to a OS thread M. Okay, each processor to a OS thread M, which then executes Go routine from P's run queue. Okay, that's a fun way. That's a fun thing. When you run a Go program, Go initializes a fixed number of processors, which defaults to number of logical CPUs. Each processor is attached to a thread, which allows the Go scheduler to manage Go routine without needing OS intervention for context switching. Okay, how Go schedules multiplex how Go scheduler multiplexes M Go routines onto N OS threads. The guy has a detailed answer for everything. Nice. Otario, brother. My back hurts. Each processor P maintains a local run queue of Go routines. Okay. When a Go routine is created, it is placed in a processor, a P run queue, a processor run queue. The scheduler will select a Go routine from the queue of the P and assign it to the available OS thread em. Okay, so think if I if I'm getting it right, it's somewhat like there are go routines and there are uh process queues, and there are machine threads. So where was I? Where was I? I just missed out. A scheduler will select go routine from the queue of thing. Okay, there's a thing called scheduler. Scheduler will go and select a go routine from process thread. Okay, G1, G2, G3, G4, something like that. And the scheduler goes and gets one go routine and fixes it onto a machine thread and says it run, bro. Okay, I can live with that. Okay, if local run queue is empty, a P can steal go routines from the run queues from other Ps to ensure that the processors and OS threads are kept busy. I like this. I like this. That's called efficiency, bruh. That's called efficiency. I'm chatting for my own self, so that's sad, but it's fine. So, can I just can any of you please acknowledge what Go has achieved? I mean, this is not something uh, that is new, if I'm not wrong. Stealing processes and like I kind of remember reading something like this in my OS chapter in back in my college days. So I I do remember going through something like this, but this is this something like this is what I did not expect. I thought it's gonna be a normal concurrency shit like um, TypeScript, but little bit more flavor onto it. But yeah, Go has outdone itself on multiple occasions on my viewpoint. From my viewpoint, like, they're solid. They are solid. Okay, lightweight stack management. Each Go routine starts with a small stack about 2 KB, which the runtime dynamically grows in strings based on the need, allowing hundreds of thousands of Go routines to run without exhausting system memory. Thank you for consideration. Yeah. Okay, dynamic. Like it starts from two. The stack starts from 2 KB and it kind of grows in strings depending on the use case. And how does it predict it? It might be something similar to a vector growing and shrinking. Uh, if that's the case, I don't know. Like I'm a bit more skeptical. Vector is quite costlier than a array, but I might be blabbering stupidity here. But I don't know. It makes sense. It makes sense. I don't really have an opinion on this. I feel fine about it. Better than TypeScript. That's my card. That is so wrong to say. Okay, this stack resaging is managed by Go runtime and avoids the fixed size stack typically of OS thread, making Go routine far more memory efficient than threads. Okay, I mean it's not like you can't do this in other languages. It's just that Go does this thing for you, so it's like taking your pain away. Blocking and non-blocking. When a Go routine performs a blocking operation such as input, output, or a sleep, it would normally block its OS thread as well. Okay, input output operation and or sleep, the thread is blocked. The Go runtime, however, handles this by parking the block routine and then detaching the OS thread M from the processor P. Okay, the Go routine, however, handles this by parking the blocked Go routine and the detached and then detach the OS thread. Okay, from the processor. Wow, the scheduler does an awesome job, and the Go runtime does this shit like I don't know, man. Like Go seems to be too good. I really love the part where where was that? Where was that? This thing stole me completely. I'm so impressed by Go right now. I could kiss the guy who started this project. That sounds so goddamn gay, but trust me, I'm not gay, but I'm code gay for this guy. Code gay. If that's a man, if it's a female, it's a manly thing to love. Unless she's 70 years old and she's in a wheelchair right now, that would be a Uno reverse for me. Sorry. Okay. Let's carry on. And the process is then freed from attached to another thread and picked. Ooh, process. And the processor is then free to attach to another thread and pick up another go routine from the run queue. Oh, yeah, this I read. Dyslexia. Where was I? Okay, huh. Blocking operations. Okay. However, the go handles by parking the blocked routine, go routine, and then detaching the OS thread from the processor. Okay, the processor is then free to attach another thread or pick up another go routine from the run queue, allowing the system to maintain high concurrency without being blocked by an individual go routine. That's awesome. So whenever I do input output or a sleep kind of go routine, a thread or operation that runs on the thread, I'm basically blocking the entire thread till it's done. So during that, it will take other go routines and pipe it onto a different thread till the thread comes back online. Am I making any sense? Hopefully I am, because I'm trying to make it sensible for me to understand. Okay. Once the blocking operation comes, the park go routine is moved back into the run queue to be scheduled. Wow, that's go routines. Preemptions. I'm reading it right. Hopefully, starting with Go 1.14, the Go scheduler introduced preemptive scheduling. This allows the scheduler to stop long-running Go routines at safe point to ensure that all routines get a fair share of CPU time, preventing one Go routine from monopolizing the thread. Yeah, I kind of think I read most of the topics here in my OS chapter back in college. But if anyone is looking for something which is close closely what tied to this article or tied to Go, I guess reading a chapter or so on OS, how OSs are made and how processors work would be a eye opener for people. I'm just blabbering here, but I would still love to go and read about input output operations, what mu ops, micro ops, the operation that runs on your CPU. And fun fact, there's front end and back end in CPU. Casey Maratori, Casey. You should definitely see this. Yeah, it's not nice that. Uh, which one? Where was it? CPU. He'll just yeah, this one. Uh, I'm not sure if can share it here. The guy is so solid when he explains. I really love the explanation. Someday, I hope I can get somewhere near that. Uh, The preemptive point are added in regular usually schedule. This allows the scheduler to stop CPU time, preventing coroutine from monopolizing a thread. The preemptive points are added to at a regular interval using usually a function call or a loopback edge, which allows for more balanced scheduling without explicit control for the programmer from the programmer. Okay, explicit control illa. Okay, makes sense. Each processor P operates with a local run queue for Go routines, but when it has no task to process, it can steal Go routines from the processor. Okay, this mechanism helps balance workload across all available processor, maximizing CPU usage and ensuring all the Go routines are actively processing. In conclusion, invocative Go routine model combined with efficient M scheduling enables developer to handle high level of concurrency with ease and minimal resources overhead. By understanding and leveraging these features, you can build scalable applications that perform exceptionally well under load. Oh, that's a good ass read for me. Thank you, Rajiv Shukla. Can I follow? I don't think so. I don't have an account. Yeah, but I would tag this guy in my LinkedIn if I can. Yeah. Mm-hmm. Can I do this post? Go. Fuck. Yeah. Arvo. Mm, I'm for people who are no one is watching. It's fine. Okay. Makes concurrency look basic. Yes, definitely look basic. Uh, Medium Shukla unlock. Okay. I guess I can post this. Comments, images. How do I see that my post went in fine? Everything went fine. Yep. Uh, yeah, people can read this thing now. I made it available for folks. Made it available for folks. It's up to them whether they want to see this thing or not. But yeah, it's quite convenient right now. Like I love this article. I loved it. Um, no. Let's fit into our use case now. So by doing this, learned. Okay, let's try to fit Go routine. Just by writing Go, it's turned into an asynchronous operation which does all this bullshit under the hood. So can I have multiple calls done on that basis? Yep, I guess so. I'll can just go run server dot go. It's running. I can just say local host. For people who can't see, I'm just calling my local host 8080 8080. GG sir. Local host 8080. Okay. And if I don't resolve it, how will it operate? If I go to handler and say okay, and stop this and run it, and will still be loading. Yeah, it returned something, still running. Yeah, yeah, local host. So there are three operations which are not fulfilled at all. Yeah, love this, love this, love this. So when I forcefully do close a connection, it kind of handles all my multi-threading problem in one go. Okay, I get it. Go, you're awesome. Go makes it awesome. Go makes multi-threading look sus. But yeah, I do remember reading it. I can limit the number of processors that Go can use, and I can I can decide which core my Go routine works on, and I mean channels work on. So yeah, let's see if I can find something on channels. Yeah, Go by example. Ooh, Ravikumar, 9 minutes read. Does someone want a Go articles? Done. Someone wants article reads? I can. Um, I will exploring the depth of Golang channels, a comprehensive guide. In this article, we'll take a deep dive into the inner working of Golang channels and explore the various options they enable. We begin by laying down the fundamentals of Go routines and channels, shedding light on why channels are essential. I invite you to stay with me through this article as altogether. Although we might start by covering basics that you're already familiar with. My reading skills are really bad, and my reading out loud skills are really bad. Okay. You get the point. Okay. Okay. It will be instrumental in typing up all the loose ends time by the time we conclude. Your patience will be rewarded as we progress. What happened what has propelled Go to fame is its exceptional concurrency support, and at the heart of concurrent execution in Go are Go routines. These serve as the fundamental units of concurrent work. Okay, managed by Go runtime, they are scheduled to run on available process threads. Thinking of Go routines as separately parallel processes within your program. Think of Go routines as separate parallel processes within your program. Okay. However, when the Go routines need to exchange information or work together, that's where communication comes into play. Okay. The question then arises, how do we make Go routines talk to each other? To enable communication between Go routines, a simple approach is use is to use a logged queue, a first in first out data structure. Senders add items to the queue, and receivers take items from it. Interestingly, Go uses a similar concept for inter Go routine communication, and they named it channels. Such a nice thing to do. Yeah. Uh, okay, where were you? Let's delve into somewhat less exciting theory about channels. Channels, the basic channels serve as means of communication and synchronization between different go routine. In fact, there are three main types of channels we can explore. Buffer channel, asynchronous communication. Buffered channel, asynchronous communication. Buffer channels, often referred to as synchronous asynchronous channel, offer more flexibility in communication between sender and receiver. These channels pose a buffer size possess a buffer size which is beneficial when the sender needs to send data in burst while the receiver processes it at a different pace. The buffer stores data temporarily allowing the sender to continue sending without immediate blocking. I need water, sir. However, it's crucial to select an appropriate buffer size. Too large a buffer size might consume more memory, whereas too small buffer might not optimize performance. To create a buffer channel of type string, god dang, water feels so good. I mean, I've been reading for what, 20-30 minutes straight. Okay, so I just write channel and tell it to make a channel of strings of size 3. This will create a buffer channel of size 3. Okay, if the buffer is full, if there is nothing to receive, a buffer channel will behave very much like an unbuffered channel. Ooh, nice. Unbuffered channel, synchronous communication. Unbuffered channels, so-called synchronous channels, are ideal to precise synchronization and communication between coroutines. They ensure that data sent by the sender is immediately received by the receiver, leaving no room for delays. It is important to note that both sender and receiver must be ready before the data can be sent or received. To create an unbuffered channel of type string. Okay. Channel make string where chan string where chan of type string. Okay, and okay. Signaling channels, async channels with zero size elements. Signaling channels or async channels with zero sized element come into play when non-blocking communication is necessary for signaling or coordinating purpose. Okay, sending and receiving data from channels. Sending and receiving data through channels is straightforward. For example, in a buffer channel of size 1, I make a channel of size 1 which is of type int, and I push in 3 to the channel and receive 3 from the channel and assign it to V. I'm pushing data out of channel, which is okay. Okay, yeah, I kind of understand it. Not completely. Channel facilitates synchronization and communication between coroutine without requiring explicit locks or condition variables. Internally works like a first in first out circular queue. Okay, channels transfer copies of object rather than actual objects. So I can I can store my outputs depending on my inputs, and I can make sure the return types returns are ordered according to my needs. So depending on the go routine that I call, if I want the go routine on the third place inside the queue, I can push it in the third place. Okay, first in last out. Okay, channel facility internally works like a first in first out queue. Okay, channel facilitates synchronization communication between go routine without requiring explicit locks or conditional. Internally works like a first in first out circular queue. Yeah, first in first out. Sorry, first in last out wouldn't make sense. By default, both sender and receiver blocks until the other side is ready. Okay, this built-in blocking allows GoRoutine to synchronize without explicit synchronization mechanism. If one GoRoutine wants to receive data from another, but the sender doesn't provide it, the channel will make the waiting GoRoutine wait indefinitely and vice versa. That's a pain part. All right, let's shift from theory to inner working of the channels, diving into channel implementation. Okay, so when we talk about implementing channels, we can picture a simple way with a queue protected by the lock. Essentially, Go takes a similar approach, and this is embodied in a channel structure. Okay, not sure. Okay, this structure plays a central role in channel implementation. Go channel implementation is centralized around three structures: a channel, wait queue, wait queue, and pseudo dog. Okay, let's focus on HN for now. We'll cover others as we progress. HN structure is the heart of how channels function internally. It's designed to handle different aspects of channel behavior, ensuring reliable communication between Go routines. While we delve into each field role as we move forward, let's have a look how channel looks like. Okay, HN struct, it has a queue count, total data in the queue, data queue size, buffer size of the channel, buff unsafe pointer, pointer to an array of data elements, element okay, close, a flag indicating whether the channel is closed, size of each element decided by type of elements. Okay, I can push in few functions of the same type in a Go routine, then expect it to behave in a certain order. Wow, and that's really nice. Okay, sendex an index of the next slot to send. Okay, receive x index of the next slot to receive. Receive queue of waiting receivers. Sender queue of waiting senders. Lock mutex for protecting the channel. Okay. Apart from send queue and receive queue, all the fields are self-explained. Let's keep aside these fields. We will delve into more detail as their usage comes. Are you really sure it's a 9-minute read? I mean, might be. Okay. While making a channel, Go allocates H structure on the heap and returns a pointer to it. So channel is just a pointer to a variable of type H. Okay. As explained above, while we init a buffer channel, it creates a buffer of channel length and waits for the NQ and DQ of the elements. Let's think there is a queue, so it puts the element in the buffer, and then the DQ pulls the element from the pull the element from the buffer. Okay, circular queue, sender index, receiver index, mutex. Channel make chan into 3. Okay, I make a 3. Each is this. Okay, then I say channel push 3. So buffer 1 is pulled. Then I say channel push 4 and 5 of type this, and 4 and 5 two more options. Okay, then receive 3 from the channel because I pushed in 3. So the next one, I get the I get the concept. I get the concept. Okay, sending and receiving messages unveiling the process. Let's delve deeper into how Go routines communicate through channels and peek under the hood to understand the inner working of the channel. Consider the following scenario: sender and receiver. In our example, we have two main Go routines: G1, the sender, and G2, the receiver. G1 has the list of tasks and send them through a channel to G2 for processing. Here's a simplified version of the code. Sender and receiver. Okay, let's just say I have array of strings task1, task2, task3, and a channel of size 3. So I do a for loop on the task range. Okay, and I push in tasks into the channel. So go worker Okay, go worker, and I pass in channel, and channel of type chan string. Okay, and for I create a variable t and process t. Okay, it's pushing back here. Okay, it makes sense. When G1 sends the task to the channel, assuming the buffer is empty, the go runtime takes something like this: G1 channel task 0, task 0 memory copy buffer. Okay, enqueue acquire lock, enqueue release lock. Okay, task 0 memory. Okay, acquire the lock, make a copy of the task 0, enqueue it in the buff. Release the lock and allows G1 on its merry way. Okay, an important point here is that the actual enqueue operation involves a memory copy. This copy of task 0 is placed into the buffer. Okay. Now G2 is scheduled to receive data from the channel and the go routines mirrors the above step. And G2 is pushed on to. Okay, I'm pulling data from G2. I get task 0 ka copy bana. Copy is pushed here. Okay. Acquire the lock on the channel. DQ. Okay. This makes sense. Release the lock allowing DQ, NQ, and DQ. The key here is that the memory buffers copies mechanism ensure memory safety. The only memory both go routine share in is the HN structure protected by the mux. Everything else, like the task themselves, involves memory copies. That's still something that I can live with. Let's delve back into the conversation. Considering both G1 and G2 have exchanged data in as discussed, now let's ponder over the scenario where we have unbuffered channels or buffer channels that's reached its capacity. Imagine G2 taking an extended amount of time to process a single task. This causes G2 to be unable to receive any additional tasks from the asynchronous channel 1. On the flip side, the G1 continues to send more tasks into the channel without being blocked. Okay. However, if we are dealing with a buffer channel that has reached its capacity, G1 won't be able to send any more tasks into it. Consequently, G1 execution comes to a halt or it's blocked, and it only resumes once the receiver operation occurs. Now we understand that the go routines are being blocked when either sender or receiver go routines are ready or queue is full. Now, how does channel know about receiver go routines and sender go routines? So there comes the usage of a receive queue and send queue from like the fields of HQ. Okay. Now let's dig into the roles of receive queue and send queue. Okay. These two are variables of a type called wait queue that holds essential information. Okay. Point to the first pseudog in the queue and point to the last pseudog in the queue. Okay. First and last, that's the structure type, wait, and struct. Okay. Sender queue are used to store blocked go routines which are trying to send data to channel. Receiver queues are used to store the blocked go routines which are trying to read data from the channels. What is pseudo? It's like a representative of go routines in the context of waiting queues, thinking of it as a carrier of information about the go routine's current waiting state in waiting in the queue. Okay. As discussed, the above two scenarios can happen. Either sender is blocked waiting for the receiver, or receiver is blocked waiting for the sender. Consider this code. Function task. Okay, channel. I push in data. Okay, I'm trying to push all the things in the task to go in. Sending task 4 to channel. Okay, okay. Go worker. Hmm, G1 and G2 worker. The sender blocked waiting for the receiver. Okay, in the above code where we are sending task 4 to the channel, we are trying to send data into the channel that doesn't have any active receivers. In such case, the blocked sender coroutine G1 is encapsulated with with a pseudo structure and placed inside the queue of the channel. Mhm. So sender queue creates this and G1, and it creates an element and pushes it. Sender forcing representation. G1 sends an element to the buffer. Okay. After okay, sending three tasks. Oh, yeah, since it has only three limited spaces, after all GG, then it will go take task 4 and call this. Ooh, do I get an output for this? Wish I could try it out. Sometime, some other time. The following things will happen. The channels are channel creates a pseudo for itself and attach it to the send queue of the HN structure. Then the channel makes a call to the go routine scheduler to park G1. The go routine scheduler switches the state of running G1 from running to waiting. Okay. Later, when the receiver is ready to receive more tasks, it dequeues the pseudo from the send queue and G1 is scheduled to run again. Resuming receiver block from the sender. Now consider the scenario where the receiver G2 is waiting for data. In this situation, G2 is wrapped within a pseudo structure, much like a sender's case. The pseudo is placed in the receiver of the channel and indicating G2 blocked waiting for data to be sent into the channel. Okay, it's just waiting there. Okay, when G1 the sender becomes scheduled for execution, there are two primary methods to resume the blocked. Okay, NQ approach. G1 enqueues the data into the channel buffer, dequeues the waiting G2 from the receiver queue, and signals the sender that G2 is ready to execute again. Optimize copying approach. G1 directly copies the task object into the memory location receiving for the G2 stack and from the pseudo element field. Okay, not that I understand it much, but I I get the basic gist of it. Now question arises, why did G1 directly copy task 0 into G2 stack instead of enqueuing it? The optimized copying approach is unconventional but efficient, gives that the each go routine has its separate stack space and go routine does not access each other's state directly. G1 can directly manipulate G2 stack pointers. Okay, and this avoids the need for GT to acquire a lock and modify the channel buffer. This optimization reduces memory copying overhead, improving the performance by reducing the overall synchronization overhead. Ah man, more information about the channels can be explored at runtime package chan.go. Oh yeah, chan.go. In our forthcoming area, we'll be exploring Mutex and Go. Oh, nice, 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 nice. The guy who wrote it, real good guy. Ravi Kumar. Nice. Big thumbs up for you. Wow. I'll be out for a bit. For 10 minutes. We'll come back and we'll try some C++ maybe. We are back. Yep. Let's try writing something which is funny, fun to write. Mm, I'm just brainstorming here. Mm, uh, we can go back and work on whisper.ppp, which I uh, used to work on GitHub. That's a fun project. Uh, I can go audio to text. This would make more sense. This is my repo. Okay. Uh, Converting audio to text using Whisper.cp could have used submodule for porting Whisper library and will take up it in future. Yeah. I guess I can do that now. I can do a submodule for this. Okay, so that whenever Whisper.cpp is updated, okay, I get the updated version of the code. And it's written in CPP, so reading it would give me a little bit more context on how it works. And I did not find any use case for it. To be honest, I had to use FFmpeg to convert the audio into different format and pipe it down again, but never found the use case for it. Never found it really that helpful. I wrote it in Rust. I can I mean, I don't want to scrap this thing. Yep, a file not found because yeah, Whisper. Yep, yeah, this is the guy who wrote it. 38k stars, well deserved. Plain C++ implementation without any dependencies. Apple Silicon first class citizen optimized via ARM Neon accelerated. Yeah, you speak, you give GG. Makes sense. This is something I worked on for a bit and I did not find it that fun to write. That's me. Sorry. Sorry you had to see me. I mean, you will get used to it. You will get used to it. 19 contributions in 2025. Should work on it. I couldn't name this thing really anything other than load mission. I don't know why I did it. Customize your pins. No, I just want to see my repositories. Yeah, Rocky. I did not have any plans for this one. Like I might have planned something. Need to plan something. HTTP currently fucking it up. On a break so far. Okay. Like let me commit the code for it. So that if there are any updates, git status, git add, and git as commit. Uh, just read about Go routine. So deal with this. Uh, huh? Yep, yep. Um, yeah. Mm-hmm. Mm-hmm. Okay, that's not fun. Uh, Trace. This is something I can work on. Devil fruit, Ben. Yeah, I should probably clean this repo up. I don't want rust here. Yeah, I was planning to use Volcano API provided by Rust, but it was too safe for me to play in that genre. API, this is done projects. My team must config. You get it. Delton beta. Yeah, Rust API, which I really tried to write, but it was utterly unsuccessful. Yeah, hook is something that I wanted to build for Angular. Oh, I have too many unsuccessful projects. Nice. Mm, let's ask ChatGPT what can I build. Uh, no, I don't want to ask ChatGPT that. It kind of pisses me off, but uh, I mean, I've been wondering about this thing for like quite some time. Like, can't I write my own hash map? Mm, I can. It seems like an interesting topic to write on. Uh, but yeah, Casey seems to be working on something fun. Deep thought on other languages like Rust and Go. Stop recommending clean code. I mean, I really want to get into this genre, but I don't have the skill set to be there. If you know what I mean. Yeah. The skill set required to be good at CPUs, it's next level stuff. But I can try reading some assembly. Yeah, I can try reading a bit assembly. Mm, where can I read something which is fun to work on? I don't want to go on web based programming right now. You know what I mean? Like I'm not in the mindset or state to write anything related to web because it really pisses me off. Like even the HTTP thing which I'm currently trying to write now, the sole purpose for that project is for me to understand Go, not write any more of this web shit. It's like it has become kind of boring when I started exploring the possibilities. If you know what I mean. Yeah, I want to explore a bit more on the programming and like where can I lie? What can I build to make it more fun? Let's see what this guy builds. GML whisperer key he. Okay, CS implementation based. Oh, the guy is goat. The guy is a goat for real. 17k followers. Oh yeah. What is this? Slack text based mock UI for Slack. GG. He just built this. Compiler director. Come on, really? You just built your own shit. How does sign out work? I don't have an account. How did he host this stuff? Llama. I guess the Hacker News title. Collaborative storytelling experiment. Okay. Okay. A long time ago in a galaxy far away from far away, it was time of civil war. What was a real before is now shockingly undergoing a vicious series of changes in Elon unexpectedly teleported himself from Mars. Okay. And every person became dog, and doggy sky jump after wall into house. Hi, this prince touch us because dog underwear wore get owned alone. Psychology test. Tutsi simple good stuff. It's mother long Russian water is Russia water this. Mm, Free. What? What am I supposed to do? Fruit. Transform. Keyword mocha tree. Transform. Okay. Water this transforms. Okay. Oh, this seems to be a fun thing. Like he built few things which are really awesome. Messaging through sound. Okay. Okay. Hello. Hey. Okay. How do I messages? Send. Hello. Hey. Am I making any sense now? Like, Spectrum. Okay. FPS. Send. Okay. I don't have the skill to operate on this. Acoustic keyboard editor based on language. Browsing hacker news in terminal. Okay, that seems more. Toggle H, toggle help window, S to status. Uh, okay. Oh fuck. How do I go back? Um, mm, Go to the top. Quit. Daily highlights of show curated by DeepSeek. Q. So can I go here? Okay. Difficult game test your logic. Mac OS app. Okay, Mac OS apps to reduce high strain. Mac OS my service Mac bar utility reminds me of a reminds you to blink more. Wow. Think Thank you all for the feedback. Appreciate it. Wow, how did this guy even pipe this thing? They update on real time too. Hmm. Are they updating? Next update. Oh, there are updates. There are updates, and I can do this in my terminal. And he made a preview so the dumb people like me can just. Ooh. A love letter to the CSV format. I hate CSV. Fuck. This guy makes really interesting shit. Like, wow. Lottery check. Search past lottery numbers in the Bulgaria. In Bulgarian. Okay. Is this even possible? Okay. View another data or so. Okay. He built too much stuff. GitHub. I know GitHub. Okay. I should figure out where do I lie in this generation of programmers. But if I okay, how many depots does he have? Pull requests. Sorry, not this. I would say repositories. 70 plus repositories. All built in C++. Vim script 2. Terminal configuration for C++ development with Vim. Mm, okay, my terminal configuration Vim/neovim using repo can mess up your existing. It's highly recommendable to first try it out with a fresh VM virtual machine. Okay, bro, install Vim neovim get starship VM. Okay, py virtual pip install neovim git clone recursive cd gtem install.sh, and he wrote an install file for it. Okay, tn to open new tab, tc to clone a tab, which move tab to position 0 to 9, go to definition. Okay, this is go to definition. Oh, yeah. Weird, but not that weird, but weird, still weird. Init.lua packages. Looks like the guy is not using lazy. I mean, a goat is a goat still then. Fuck me, I don't know much. Kitty. Okay, he wrote his own theme too. The guy is a genius for a reason. Sticking with one language helps. Hmm? But yeah, C++ helps you to build stuff, man. Like, let's see how much did this guy build. Text prompt generative audio, high fidelity neutral audio compressed language models are a few short learners. Okay. Yeah, GG view or hey, hey, hey. I feel tired. Yeah, I got a full-time job in the morning, so it's obvious that I'll feel tired. I feel tired, but yeah, some more time. It's 1:56. Oh, that's my queue. 120 in 1 hour. Yeah, let's just try. Why not? Mm, I'm still in a dilemma. How do I go from here? It's like a midlife crisis for me. It's like if I move right, I can just be on the good part where everything is easy for me. Web, web, like I pretty much don't know the entirety of how web works, but I can figure it out if the problem arises. That's how confident I am, and me being really confident is bad. So I'm trying to find something which can keep me engaged for some long time. Yeah, and the most confusing thing. What is that? Render triangle using open using solver. Yeah. Now let's try to figure this thing out. 114, no, literally, check it out. Yeah, you get the one triangle. But is it Windows specific? No. Glad.h, I don't know what it is. IOStream, I get it. GLFW3, okay. Vertex shader, fragment shader. They should be built and deleted. And somewhere around here, they should be a delete operation. Yeah, two. Do I have a GC? I guess I should have GCC. I mean, that might be a good use case for Rocky. Hey, my boy, let's get you down. Want to be in C++? Let's go, ma. Files. Oh, Rocky already here. Rocky, you there, beta? Yep, Rocky already there. CPP. Uh, let's go here. Let's try to draw this. Get this down and make it work. I mean, I'm really interested in this one. It's and I don't think I have any LSP for C++, but yeah, having an LSP might work better for me at least. Wait, in this, whenever I do fmt println, it's just my bad. I did not do the needful. I can just go here and say, Mason, kindly get me CPP, CPP, GCC, G++, C++, Cortex debugger, yeah, CPP lint, C, Harper, ls, illa, lint, illa, trivi, illa. Most of the things are implemented. Let's go. I don't know what this is. How does my LSP not function, ma? Why you know function? Let's update this. In triangle in OpenGL. Not too hot, right, bro? Oh, you're flaming. The guy was flaming. It's like my PC is on fire. GCC triangle. Yeah, no such file as glad.h. I don't know what a glad is. Let's go figure out. Okay, glad dot h CPP. I'm following this to but I'm same problem. Okay, if you're looking for simple example, you can remove glad and remove glad.h include and okay. In further, if you're on Linux Ubuntu, for example, you don't need glad, just add this headers instead. Okay. um, if I'm in Ubuntu, yeah, I am in Ubuntu. Hopefully, yeah. No, sir. GLFW3, GLFW3, GLFW3 in Ubuntu. Okay. Install on a system with CMake, CMake package. How does things work in this, man? Go to home directory, clone the repo from the git, and CMake Unix make files. And sudo apt build depth GWF3. I ran both the commands. Sudo. You may need to run finally run make. I first need to figure out what does this do in order to figure out why is it needed. If I may ask, TLFW 3, and somehow I can access all the things. Great. Okay. Not even kidding. Glad load, and where is uh GL attach shader? GL can't attach shader because GL create program is not available, and EGL and get open GL working in Linux. Terminal commands. Terminal command to show OpenGL version. Sudo apt install Mesa. You can use then Mesa. Okay. Gotta build shaders and stuff. Before that, I need to figure out how to get the pipeline up first. The pipe. How to install OpenGL to set up. Okay. Introduction OpenGL cross language API that provides us with large set of functions to render 2D and 3D. Okay. UDA. Okay. I need to install CMake packages. Okay. Okay. And yeah. Install Mesa utilities, Lingua Mesa and common defs. Let's just copy and paste. Yeah. Okay. And I need what? GLFW3. I guess that this is what we are talking about. కాలింది లోపల కలియున నచిన. Oh, this is fun. I need to go get this last one done. Yeah. 34 MB of additional disk space. Come on, OpenGL, make it worth it for me. I need my triangle. I mean, I can't be pretentious right now because I already been through this like tutorials, few things I just passed through them and figured out how it actually looks and the end product works. But yeah, before you start with creating stunning graphics, you need to initialize OpenGL context and create an application windows to draw in. We'll do this using a popular C library, GLFW, Graphic Library Framework. Okay, this library also helps us to handle put input from the joystick, keyboard, and mouse. Running the below command would install in your system. cd local libraries. cd local libraries. Okay, I change directories, then I'll go git clone this bullshit. Oh, sudo will help. Yeah, you fucking thing. Yeah, you fucking thing. cd glfw. And after cding, what should I do? Cmake and make sudo make install. Cmake dot unable to recreate the package directories. Why? cd glfw cmake illa usage cmake option path ls c. Okay, wait. cmake okay, cmake, where is cmake uh pum pum. As we know, OpenGL. Fuck you. Wow. Mm, okay, wait. Why live? Can I make it available everywhere? Is it the reason? He make this modi plus x cmake uh, changing permission of cmake operations uh, seven c make. Okay, unable to recreate the private package directory. Okay, let's see what the problem. Let's see what the problem. Let's go Google for problem. Okay, cannot double file to write the occurs when cmake has no permission to write a given file. In case involves directories under which are usually configured as read, and the file cmake.txt is created in the build directory. So the error message about such file usually means problem with build directory. A directory should always be writable by the regular user. Here cmake creates files for build tools and okay, I'm running cmake presumably portable zip somewhere launching without exact error message. It is difficult to guess the reason problem, but your new is executable the main problem. Okay, I think these questions are better answered on Stack Overflow to do this with the laptop regardless if Okay, so I haven't someone else. The OpenGL might not be an issue. The idea maybe think is uh, no, it's just a problem of permission. Sudo ch plus x for glf and cd glf. No, cd glf cd c make files. Oh, I guess I cannot. Ll. Okay. Uh, L- library. It has a read, write, execute for only root. So can I just ch mod plus lib permission illa sudo chmod plus x for lib. Man, my bad. Okay, lib. I might be breaking few security concerns here, but let's try. Unable to recreate the private package directory. Private package directory. So wait, I'll try git clone here. I'll just try to do it here. Uh, Instead of pushing it there, I'll do it here. I know it's redundant. I'll go cd glfw and cmake. Cd glfw ls rm rf glfw. Now make the git clone. Cd glfw cmake dot. Yeah, it can. Cmake error header not found. Install x lib. Okay, apt install lib xiner ama audio install. Missing destination file operand after install apt. Okay. Uh, let's go get this thing up. Too much. How do I put it? Too much pressure. Can't install lib2dev cmake glf. Why can't install cd? Sudo app install. Navigate to the Unix makes files. Sudo. I, I might be really dumb in this case. Uh, yep. Okay. Uh, we make not found. Okay. C make. Uh, yeah. This is something I might have to write. Love. No source binary provide. Both will be assumed to be same current, but not include will under support. Install. Come on. What does CMake want now? CMake. CMake list text. Uh, okay. Uh, cd g and CMake dot. And what am I missing here? Uh, mm, I did not get the grep up yet. When that's a point of concern. Yeah, I'm starting to get used to lengthier streams right now. Hopefully, that's a good thing. Uh, yeah, I don't know. Oh yeah, fuck. Wait. Let me go to my GitHub. Uh, where is my NeoVim? Not updated. Where are my remaps? I just need this one remaps. Uh, leader, not leader. Yes, it's yeah. Even this too will help, but leader, leader PS, leader PS, leader. Sorry, leader PS, leader PS, leader PS. I need my leader PS. Where are you? It should be inside the gripper service. Um, After uh, telescope. Yeah, leader PS. This is something I really miss right now. I uh okay. Okay, wait. No gripper. Leader P. Okay, attempt to index global built-in nil. Function string source no file. Why no file, ma? Why? Okay, did I do something? Oh, okay. Built-in is like required telescope built-in. Do I have telescope with me? I guess I do. Hmm. Okay, I'll delete this. Hmm. Dima, 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 dima. Telescope built-in fuzzy finder. Oh yeah. Find files I know. Git files. Keep it here. Oh yep. I'll refactor it some other time. I just need the grep to work. What's the problem now? Require telescope built in. Is that the problem? Okay. Wait. I can just uh, okay, it's not a git repo. Yep, grep seems to be working fine, sir. I should write a fallback for it probably, but it's fine for now. What do you say? Oh, bro, no inconsistent. Oh, my laptop. That. Oh, I'm sorry, baby. Did I hurt you too much? I guess I did. Yes, I did. Hmm. Mm-hmm. Uh, Dima, 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 Dima. Mm-hmm. I can. I mean, I don't want to give up right now. It would be boring as fuck if I give up right now. So we make okay and not found what um not found libx. Uh, what does this do? Uh, Cursor management library. Okay. See, Brew can do it. Please don't be a conflict of packages now. Yeah, 30 outdated formulas. Uh, okay, wait. Uh, yeah, after getting CMake done, how do I check if that thing is working fine or not? Uh, Alright, let's look for what does this command show. Package config package cursor nothing. Include somewhere cd package config brew. I can just do brew list now. It will show what do I have x renderer x cursor. I have x cursor. Mm, not found. Search package path. Perhaps you should add directory containing uh, to package config environment variable. Package requires virtual world not found. How many dependency pictures pieces are there inside this? Fuck it, I'll do it tomorrow. Sorry guys. Like I just wanted to do it today, but I feel way too much sleepy. It's 2:30 in the morning right now. Yeah. You're watching the end. I don't know why you're watching it, but I still appreciate it. Thank you for sticking around and subscribe if you can or want to. Jai Shri Krishna. Bye bye.